Welcome back guys. In this video we will be covering few special operators and operator precedence. First special operators we have is comma operator. This operator is represented by the token comma. Comma operator has lowest precedence and left to right associativity. We will be learning what is precedence and associativity at the end of this video. Comma operator works as follows. That is, suppose we have resultant is equal to expression 1, comma expression 2, then first expression 1 is evaluated and the result is ignored, and then expression 2 is evaluated and the result is assigned to the resultant here. This is a binary operator that evaluates the first operand and discards the result, and then evaluates the second operand and returns the value. Comma operator can be used in three ways. That is, it can be used as separator, as an operator, comma operator in place of semicolon. Let us understand how this operator works in different type of expression with the help of some examples. First is comma operator as separators. In this, comma acts as a separator and it separates this a is equal to 1, b is equal to 2, c is equal to 3 and I is equal to 0. These are the value we get as the result if we want to print these values of the variable. In our next example, in this case, a will be first assigned to I, b and c value will be unused. If we will be printing the values inside this block, then we will be getting value as 1 for A, zeros for B and C, and I is equal to A, that is equal to 1. But after this block ends, the changes made inside this block is lost and the original values will be displayed. That is 1 for A, 2 for B, 3 for C, and I is 0. In this example, A will be assigned to I, B and C are unused. It's equal to something like this. And if we want to print this value, A will be 1, B will be 2, C will be 3 and I will be A, that is equal to 1. Next we have comma operator as an operator, assuming these are the values of our variable. As we have given a bracket here, in this case, comma acts as an operator and B's value is assigned to I and A remains unused. A is 1, which is the initial value, 2 is the value of B, which is again the initial value of B, 3 is for C, which is the initial value of C, and I is equal to B, which is 2. Next we have this. In this case, first value of A is increased by 2 and A plus B value is then assigned to I. That's why value of A is 1 plus 2 is 3. B and C are 2 and 3, which are the initial values of B and C, and I is equal to A plus B, which is 3 plus 2 is 5. Next is this example. As we have B here, after which the bracket ends. That's why B will be printed as the value of I, and rest all are unused. This is equivalent to something like this. A's value is 1, which is the initial value, B 2, C 3, I is equal to B, which is 2. In this case, we have C near the bracket, so C's value will be copied to I. A, B, C will be the initial values of A, B, C, that is 1, 2 and 3, and I will get the value of C, which is 3. This is equivalent to something like this. In this case, as we don't have any bracket here, that's why A plus equals to 2 value will be assigned to I. That is 1 plus 2, 3. And this is unused. A is equal to 1 plus 2, that is 3. B and C are 2 and 3, which are the initial values. And I is equal to A plus equals to 2, that is 3. Next is comma operator in place of semicolon. In this case, the variable declaration statement must be terminated with semicolon like this. The statement after declaration statement can be terminated by commas, like you can see here. Last statement of the program must terminate with a semicolon like this. This program will display the value of A first, which is 1, then gives a new line, then displays the value of B, which is 2, then again a new line, and then gives the value of C, which is 3. Next we have size of operator. It is a compile time unary operator which can be used to compute the size of its operand. This operator accepts one parameter or operand which can be used in two types. First is when operand is a data type. When size of operator is used as a data type such as char, int or float, it returns the amount of memory allocated to that data type, that is 1 for char, 4 for int and 4 for float. We have some examples. Value of char is 1, sort is 2, int is 4 and so on. Size of operator results may vary depending upon which among 32-bit size or 64-bit size compiler is used for our program. Like in this case, suppose you are using long and you are using 32-bit size, then it will display 4 byte as the result. But in case you are using 64-bit size, this will display 8 as your result. Next is size of operator with expression. When size of operator is used with the expression, it returns the size of the expression. Like here, int a is equal to 0, bit range is 4, double D is equal to 10.2, double has bit range 8, and we want to print size of a plus b. In this case, largest among both the data types of the variables, that is int and double, will be the result. That is, from int and double has largest byte range, that is 8. So 8 will be the output. Next we have increment decrement operator. This is a very important concept and we will be using it a lot in our future videos. we have four types of increment decrement operator. In first we have pre-increment operator. Here the value of x is first incremented by 1 and then the value is assigned to y. So y will have the incremented value of x. Like this is the initial value of x. First 4 is incremented, that is 5. Then this 5 is assigned to y. Postfix increment operator. In this case, the value is assigned to y first and then the value of x is incremented. So, y will be having the original value of x. Like here in this example, initial value of x is 4. 4 will be assigned to y. Then the value of x will be incremented to 5. Similarly, in prefix decrement operator, x is first decremented by 1 and then the value of x is assigned to y. 4 is converted to 3 first, then this 3 is assigned to y. And in post decrement, first the value is assigned to y and then the decrement takes place. That is, the y has original value of x. 4 is first assigned to y, then the decrement takes place. Let's see how to use these operators in C++ program. Suppose value of a is 1, d is 10, and this is the declaration of b, c, e, f variables. In case we are doing a increment into b, then in this case, first a's value is assigned to b, then a plus 1 is done. That's why a will have originally the value as 1, but after postfix its value is 2 and b's value is 1. In case of prefix, first increment will be done of the value of a, then that value is assigned to c. That's why a and c both will be having same value, which is 3, as you can see here. In this case too, first assignment is done, then decrement is done. That's why E will be having the original value of D, which is 10, like you can see here, and D will be having the decremented value, which is 9. In this case, both F and D will be having same value because D will be first decremented, then assigned to F. That's why both are having 8. Now let's see how input-output is done in C++. First one is cout, standard output stream. Cout connect to standard output. It uses insertion operator to insert values. Cout is pronounced as cout. As you can see in this example, we have used cout statement to display hello world in our output screen. Next is cin, standard input stream. Cin connects to standard input. It uses extraction operator to extract data from cin object, which is entered by the user using keyboard. Cin is pronounced as cin. As we can see in this example, cin is used to get the value of age of the user from the user by input. When the user inputs the value 17, the output is displayed with a message use your age is like this. Our last topic is operator precedence. If there are multiple operators in a single expression, the operations are not evaluated simultaneously. Rather, the operators with higher precedence have their operations evaluated first. Now, what is associativity? In programming language, the associativity of an operator is a property that determines how operators of same precedence are grouped in the absence of parentheses. Associativity, unlike precedence, is not what evaluates first, but it is about how the expression is passed. Parsing is dividing of sentences into grammatical parts and identifying the parts and their relationships to each other. Here, the operators with highest precedence is placed at the top of the table and the lowest precedence is placed at the bottom. Operators in postface block has higher precedence than unary, and that of unary operator has higher precedence than multiplicativity. But as far as associativity is concerned, in this single block of additivity has left to right associativity, that is, the expression will be evaluated from left to right in case both of these operands are available in the expression. Now let's understand it a bit. Suppose these are the values of A, B and C and we have this as our expression. Then first, in case of operator precedence, we learn that multiplication has higher precedence than addition. That's why first multiplication is done. That is A, which is 3, into B, which is 2, is 6. Then this 6 is added to C, which is 1. That's why this will result to 7. In case of this expression, again the multiplication is done first, then the addition is done. That is A, 3, B, 2, 3 into 2 is 6, which is added to C, which is 1. In this case, again we are getting 7. But in case of associativity, suppose this is our expression, the execution will start from left to right as written here. First the subtraction is done, then the addition is done in this case. A, which is 3 minus 2 is 1. This 1 is added to C, which is 1 again here. So 1 plus 1 is 2. And in this case, the execution will be done like this from left to right. First the addition is done, then the subtraction is done. A plus B is 3 plus 2, that is 5, minus 1, that is 4. Now let's go through some examples. Suppose this is our expression and we know that bracket has higher precedence than multiplication and division. That's why first this is evaluated. A plus B is 1, 1, 0 and this will then multiplied because now associativity comes into consideration. These two are multiplied, then division takes place and the result is this one. In this case, first the inner bracket is solved, then the multiplication is done and then division is done. First both the Brackets are solved in this case and then multiplied like this. In this case, first the bracket is solved, then division is done, and then it is added to A because plus has lower precedence than division. Friends, in this video we learned about special operators and operator precedence. In our next video we will be learning about exponential representation, type conversion and typecasting. Please check the description box for the link. Do not forget to like, share, subscribe and press the bell icon. Thanks for watching.